Hey guys, I know that some of you like planetary videos, so for today, after our trips to the Sun, to Venus, Mars, Jupiter, and even exoplanets, I would like to take you to Saturn and its mysterious rings. So please adopt a comfortable position, have your headsets ready, because our journey is beginning right now. Saturn is one of the few planets, like Mars, Jupiter, and Venus, that can be observed from the Earth without any telescope. So it has been known by men for several millenniums, but it is only in the 17th century that more precise observations were made by various astronomers, and that the rings of Saturn were discovered. In the 19th and 20th centuries, more precise theories were elaborated about the composition and the history of this planet, and in the past few decades, especially thanks to several probes like Pioneer 11 at the end of the 1970s and Voyager probes in 1980 and 1981, more precise observations of its surface, its rings, and its satellites have been made. About 10 years ago, another very important mission, the Cassini-Huygens probe, named after two of the first astronomers who observed Saturn in the 17th century, reached the planet and permitted to learn quite a lot about it and its satellites. The distance between the Earth and Saturn, like for all the planets in the solar system, is constantly changing, because each planet is revolving around the Sun on a different orbit. But if we wait for Saturn, the Earth, and the Sun to be perfectly aligned, when the distance between the Earth and Saturn is the shortest, we still need about 1 hour at the speed of light to travel from our planet to Saturn. And of course, as we are traveling by the mind, our journey to this planet is going to be much shorter. We are going to cross the orbit of Mars on our way to Saturn, and then much further the orbit of Jupiter, before reaching Saturn, which is the second biggest planet in our solar system. And like Jupiter, which is the biggest and that we already visited recently. Saturn is a gas giant with a similar composition and probably history too. It is made of hydrogen mainly, which has aggregated around a core that is supposed to be rocky. The core of Saturn could be bigger than the Earth itself, and the gravitational force of this core would have permitted the aggregation, the concentration of gas that was floating in space when the solar system appeared. And like all gas giants, Saturn has no surface. As we now approach the planet, we see the superficial layer of its atmosphere, which is moving extremely fast. Saturn needs about 29 of our years to complete a revolution around the Sun, so that 1 year on Saturn is 29 times longer than on the Earth. But the rotation of the planet on its axis is much faster than the Earth. The Earth needs 24 hours to complete a full rotation 1 day, when Saturn needs only a bit more than 10 hours. So 1 day on Saturn lasts less than half a day on the Earth. And the superficial layers of this atmosphere of Saturn are agitated, constantly moving because of very powerful winds and storms that constantly modify the appearance of the planet. Like Jupiter too, Saturn has no surface. The gas, mainly hydrogen, which is the most abundant form of matter in the universe, is increasingly dense and hot as we advance from the surface or the superficial layers of the planet towards the center. And the state of this hydrogen is changing with a higher pressure and a higher temperature. After a few hundred kilometers within the planet, it becomes almost liquid, and if we continue to advance towards the core of the planet, it even becomes almost solid, in a state that physicists call metallic hydrogen. But I already talked about that in the video about Jupiter, and it is generally assumed that Saturn has a quite similar composition and history. It is nevertheless a bit less massive than Jupiter, but still within the volume of Saturn there would be enough place to have more than 600 times the volume of the Earth, which makes Saturn a giant planet in comparison with ours. Despite the incredibly high pressure and temperature in the core of Saturn, the planet, like all gas giants, is not massive enough to make the atoms of hydrogen start to merge between them. There is no reaction of fusion in the core of the planet, and this is what makes the difference with a star like the Sun. These gas giants are stable and they do not turn into giant reactors like the stars. But as we now leave the core of the planet, we are going to have a look at these magnificent rings around Saturn. They are both extremely large, thousands of kilometers, and extremely thin too, probably not more than a few hundred meters. And there are various theories about why and how these rings have appeared. They are essentially made of ice and rock orbiting around the planet with constant collisions between very small objects and larger ones that can sometimes be several hundred meters long, and the objects that compose these rings are constantly colliding. They aggregate to form bigger objects, then they separate, and actually the rings of Saturn are much larger than we imagine looking at photos. It is just that the farthest rings are not dense enough, luminous enough to be visible, but at the periphery of Saturn, on a distance that represents several times the diameter of the planet, there are rings orbiting around Saturn. There are two main theories about the creation of these rings. One is that these are the remains of all the matter that concentrated to give birth to Saturn when the solar system was appearing. And another theory is that these rings are the remains of a large satellite that the gravitational force of Saturn would have dislocated because of the tidal force. The tidal force is like a side effect of the gravitation. When there are objects orbiting around each other, like, for example, the Earth and the Moon, the gravitation does not make them just move in space, it also modifies their shape. And this is the main explanation for the existence of tides on the Earth. The Moon and the Sun are constantly affecting the shape of the Earth, flattening it and then letting it return to its original and more spherical shape. And this is what explains the variation of the level of the seas and the oceans every day on our planet. The Moon is also affected by a tidal force coming from the Earth, and its shape is constantly changing slightly. Now, if a satellite is relatively close to a very big planet, the tidal force can be powerful enough to dislocate the satellite and spread its components on an orbit around the planet. And this could explain why the rings of Saturn contain so much matter, so many objects. They may be the remains of an ancient moon, an ancient satellite of Saturn that would now be dislocated around the planet. But there are not only rings around Saturn, there are also fascinating satellites such as Titan or Enceladus. Enceladus is a relatively small satellite. It has a diameter of only 500 kilometers, but Titan is much bigger. Actually, it is bigger than planets like Pluto or Mercury, and both satellites have aspects, particularities that interest astronomers a lot. They both are rocky satellites. Titan has an atmosphere, even though one that is extremely different from ours, but the components and the conditions that are theoretically necessary for the life to appear could be present on both satellites. There is liquid water, probably, even though it is far below the surface, because the temperature is extremely low on the surface of these satellites. There is organic matter too. There would be like lakes of hydrocarbons on both of them, and maybe conditions of temperature below the surface that would allow forms of life, probably, if it exists, microbian life, to appear. Now we don't know, and it will probably take years, if not decades, before probes, maybe rovers, able to explore more precisely these satellites are sent. But in coming years, several missions, several projects are going to focus on the study of Titan and Enceladus to try and confirm or abandon these theories. We are now going to return to our planet, and as usual I hope that this little trip to space has been enjoyable and interesting, and I hope to see you soon for another topic. Bye bye.